Hi Year 12s. In the last video, we revised the basic probability that we have learned, and today we're looking at two different types of random variables. There are two types of random variables, which are determined by the outcome of a random experiment. The first is discrete random variables. These can only take particular or discrete values. For example, rolling a dice can give us 1 out of 6 different options. The second type are continuous random variables. These can take any value in a given interval. For example, the probability that a long jumper jumps x meters. X, in this case, can be any real number in an interval. It could be 5 meters exactly, it could be 4.27 meters, it could even be 6.00000034 meters. There are infinite possibilities. Today, we are mainly focusing on discrete random variables. As the name suggests, discrete random variables can only take particular, discrete values. They are numbers that are countable and are described by a probability distribution. They can be represented by a table, a graph, or a formula, which takes into account the probability, p of x, for every value of x. Now, let's look at probability functions. There are 3 rules that we need to remember when we are doing a probability functions question. Firstly, the value of p of x must be equal to or greater than 0, and equal to or less than 1. Secondly, the sum of all values of p of x must be exactly 1. And thirdly, in order to determine the probability of x in the interval from a to b, the values of p of x from x equals a to x equals b are added. Let's look at a practice question from the 2013 VCAR exam. The probability distribution of a discrete random variable, x, is given by the table below. Show that p equals 2 out of 3, or p equals 1. As the sum of all values of p of x must equal 1, in order to solve for p, we need to add all the values of the probability that x equals x together and make them equal to 1. With the equation shown, we can solve for p and get 1 and 2 out of 3. Now, let's look at how to measure the centre of a probability function. We can do this by calculating the mean, the median, and the mode. The mean is also known as the expected value, and it is used to determine the true mean value of a random variable from the probability distribution. For example, let's say you roll a die. The probability distribution is very simple. The expected value is what you would get, on average, if you rolled an infinite number of times. In this case, that's 3.5. Obviously, you can't actually roll a 3.5, but the expected value doesn't need to be one of discrete possibilities. So, how do we calculate the expected value from a probability distribution? It is determined by adding the product of all the values of x and the probability that x takes. That may sound a little confusing, so let's go through an example to explain it. Let's look at a practice question from the 2013 VCAR exam. This question is related to the previous question. The value of p is given as 2 out of 3. First, we need to substitute this number into the table, so we can have real numbers for this probability distribution. Then, in order to find the expected value, we take each value of x and multiply it by the probability of that outcome. For instance, the probability that x equals 4 is 0.1, so we multiply 4 by 0.1 to get 0.4. When we've done that for every value of x, we add all the results together, and that is the expected value, or mean, which in this case is 1.86 recurring. Now, let's look at the mode. The mode is the most probable value of the random variable, and you can think of it as the value that appears the most in a set of data. So, if we look at the table, we can clearly see that the value 3 has the highest probability. It appears 1/3 of the time. So, the mode is 3. Finally, another way to measure the centre of a probability function is to find the median. The median is the middle value of the distribution, in which 50% of the distribution is larger than the median and 50% is less than it. Looking again at the original table, we can see that 46.7% of the time, the value of the number will be less than 2, but the probability that it is less than or equal to 2 is 56.7%. This means that 2 sits on the range of 50% of the distribution being larger than it and 50% being smaller. Therefore, it is the median value. So that's it for the topic of random variables. Happy studying!